Physical chemistry is the study of underlying principles that govern the properties and behavior of chemical states. Physical chemistry can be studied from either microscopic or microscopic viewpoints. Microscopic meaning based on the concepts of molecules, based on and from a macroscopic viewpoints, we just study from large scale properties of matter. Large scale. Physical chemistry can be divided into 4 categories, to 4 areas. For example, so physical chemistry can be divided into 4 areas. So physical chemistry. So 4 areas. We have thermodynamics. We have kinetics. We have quantum chemistry. And finally, we have statistical mechanics. So first, we shall deal with thermodynamics. Now, thermodynamics is a Greek word meaning heat and power. Thermodynamics is the study of heat, work, energy, and the changes they produce in the states of a system. So thermodynamics studies the relationship between the microscopic properties of a system, meaning things that we can see on a large scale. Now we have equilibrium thermodynamics and irreversible thermodynamics. Equilibrium thermodynamics deals with systems in equilibrium. Irreversible thermodynamics deals with non-equilibrium systems and wave processes. Thermodynamic systems. So thermodynamic system is part of the universe under study in thermodynamics. Surroundings, parts of the universe that can interact with the system. So for example, we may have an open system, enclosed system, isolated system. An open system is one where transfer of matter between the system and surrounding can occur, while a closed system is one in which no transfer of matter can occur between the system and the surrounding. And then we have an isolated system, is one that does not interact anywhere with its surrounding. So obviously an isolated system is a closed system, but not every closed system is an isolated system. So I'll give you an example. So an isolated system is not a matter and energy can be transferred between system and surroundings. An isolated system is a closed system, but not every closed system is isolated. So for example, so this is an example of a closed system, but it's not isolated because the surrounding can interact with the system. So a thermodynamic system can is either open or closed. Isolated or non-isolated. So a system can be separated from its surrounded by various kind of walls. So we can have a rigid wall, and we can have a non-rigid wall. A non-rigid wall is a movable wall, and a rigid is a wall that cannot be moved. And we can have a permeable wall. And the impermeable wall. So meaning matter can pass through the system. Matter can pass through. And impermeable meaning nothing can pass through. And we can also have a adiabatic wall and a non-adiabatic wall. So, for example, adiabatic wall is a wall that does not conduct heat. Non-adiabatic walls does conduct heat. It's how they conduct the wall. So, for example, if we have a system, let's say we have a system, surrounded by a permeable wall. Rigid. And also a diabatic wall. This is an example of an isolated system. So for example, this is an example of an isolated system that cannot interact with the surroundings. Why? Because the system is enclosed with an impermeable wall, meaning nothing is moving, and it's sealed with the adiabatic walls, meaning the system cannot conduct heat and the surrounding cannot interact with the system. So whatever we have in the system is isolated, meaning 100 years from now, whatever we have in the system will still be in the system, because the system cannot interact with the surrounding, and the surrounding cannot interact with the system. So pretty much that's what it means.